now like to invite Rajiv Sarin, who's the Managing Director of Alfa Laval's OceanGlide Air Lubrication team, to come and present at the lectern. Thank you.
Good afternoon, friends. Thank you, TMS. It's an honor to be here and in this forum. I think we had a very interesting discussions since morning and here, and I have a lot of notes. I'll not go back and forth. What I'm here to talk to you about is some of the technologies which we are working on in Alfa Laval. But before I go into that, while I was coming, I'm based out of Rotterdam, and I'm heading the air lubrication business for Alfa Laval globally. And while on the way here, I was reading an article, and it really, kick-started something in terms of, how marine industry works, how the shipping cycles are. And before I go into that, we have been sitting too long. Maybe a show of hands of how many people have been in the industry between 2001 and 2010. Yeah, quite a few. And I think we'll not go around, but there's one thing which was key during that, and specifically 2001 to 2009, was really the boom in the shipbuilding market. We have never seen those kind of orders coming in. I was based in Shanghai at that time, and we had seen shipyards being built, greenfield shipyards, and everything was being built up in the farms, in the villages. And then it stopped in 2009. Looking at the cycle and the vessel lifetime, now that 15, 20 years period is going on. So if you really look at the average lifetime of a vessel, we are looking at the next boom coming, because all those vessels which we have been using it for all those times are going to go out. And we just realized the number of shipyards have gone down. We have seen, Dr. Ibrahim had a lot of questions. We put a lot of commercial dilemmas, very probing questions, regulations, and the shipyard capacity is going down and no slots available. So to be or not to be, it's going to be a very interesting decade for all of us related in the maritime industry. Moving on, I'll just go through some basic introduction of where Alfa Laval is. Not go through into the regulatory landscape. I think we have seen enough of slides, and the slides which has no spaces for more regulations to be taken in. Look generally at one of the technologies which helps in the decarbonization journey with air lubrication. Where does it come in? How does it help? And a little bit on about how Alfa Laval is into that technology moving forward. Okay. But before, we go into that, you must be aware that Alfa Laval, has been in the market and maritime industry for more than 100 years. We have products and solutions for all major key applications on the vessel. Sustainability has always been in the heart of us. And this is where OceanGlide just fits into the purpose as well. Because with OceanGlide, we can offer vessels, with a significant increase in the energy savings and with a corresponding reduction in emissions. In terms of the product portfolio, there are a lot of pathways to decarbonization. And we are working, and two things which are clearly coming is energy efficiency, which remains in our heart, whether we are using heat exchangers or we are using technologies which are related to the separation, or something with the clean energy, because we are working on a lot of different technologies, whether it is wind propulsion or something new like OceanGlide, which is more about air lubrication. And then it comes back why. I think it's not only the business need, but it is also about sustainability and what we can do and what is our responsibilities. We have spoken a lot about there is, collaboration. It comes out one after another, after another. We need to go into the new buildings. We need to look into the expansion. We're not looking at the yard capacities. We have, decarbonizations. There are uncertainties on the technologies, uncertainties on the fuels. At the end of the day, one of the conferences, somebody said, Rajiv, we will go with whatever is available and whatever is the cheapest. So, because the businesses are there to make money, and it's not only about that, but it also needs to be commercially viable. We talked about, Captain Tyagi talked about the crew. Yeah, we cannot forget, that's the biggest element here. The technologies need to come in, they need to be developed faster, they need to be available, they need to be simple, and they need to be robust. And who's responsible? I think it's not a single company or a provider who can do this today. It has to be partnerships, it has to be collaborations. If we want to take a new technology and build it up faster, it needs to be a full collaboration. We need to work with the ship owners, we need to work with the charterers, we need to work with the class, we need to work with the training institutes. All the people involved have a responsibility to move this forward. I think June presented this. This is coming from IMO, basically. Now, it's very clear. There are a lot of different things which are required to be done, and there is not a single solution. Somebody said in the morning, you can add up some percentages and you'll go above 100%. Yeah, is it possible? No. So, there will be multitude of technologies, there will be combination of things which need to be done to support this journey. IMO slide is very clear that you need a lot of, technologies to come into play and different areas. It talks about hull and superstructure. And this is where the air lubrication becomes a substantial part. And fluidic air lubrication takes the major portion here. And also as a part of our portfolio to support this journey. Yep, so before we go into OceanGlide, we have already looked into the context of the regulation and how does it comes into play. So let's look a little bit more into what happens. Where does air lubrication generate? Air lubrication is not new. Air lubrication has been there for ages. Alfa Laval first patented air lubrication, or not air lubrication, or air cavity, different type of technologies, in 1862. Air lubrication was used during World War II, but it was more to make the submarine silent and undetected. And that's something which is again coming a different regulation. And in MABPC 80, they have started talking about underwater noise. So there are a lot of regulations which are coming. The regulatory landscapes are changing. We heard India is looking into something, UK is looking into something. So today, the ship owners are faced with a dilemma of what to do, because there are local regulations which are becoming stricter and stricter, and it needs a lot of work to be done. So now, it's basically, when we look at a vessel, there are three forms of resistance. It's your viscous or the friction. Then you have, characteristic wave making, and then it is air resistance. And the vessels, which we normally work with in the commercial shipping, are slow speed, because at slow speeds, the friction resistance or the viscous resistance is the major part. And as the speed goes up, the wave making resistance, because of the hull shape, starts to play a bigger role. So if we can work on that frictional resistance, we can work on the specific drag reduction. The higher the drag reduction we can achieve, the lesser friction would be, lesser fuel consumed, and lesser fuel consumed means lesser carbon dioxide emitted. 1 ton of fuel gives 3 tons of carbon dioxide, and if you multiply with that with the EU ETS, which is volatile, $80 to $120, so it's a lot of money which comes into the play. If we move on to just the air lubrication side of it, there are different technologies in air lubrication as well. And I will not bore you a lot. You have bubble drag reduction, which is the traditionally available systems today. Then you have an air layer drag reduction, and then you have partial cavity drag reduction. This is a curve with one of the professors, and basically you say if you are able to inject a sufficient amount of layer into the near boundary layer, and you can maintain an air layer, you are able to reduce friction, or you can cover more wetted surface area efficiently and then with a lesser power. So the bubble sizes go, bubbles coalesce to form an air layer, and then you have lesser, with the same compressor power, you can go higher on the efficiency and increase in the drag reduction. So this is where the air lubrication comes into play overall. If you look at, coming back at Alfa Laval, what we did, so we are at air layer drag reduction. We actually integrated two technologies. Now, air lubrication, I said, has been very old, available for a long time, and fluidics itself has been available for a long time. So the new thing is integration of both these technologies into one. So that's why we have it called something called fluidic air lubrication, and we are able to come to air layer drag reduction. That's what it is there. Basically, what it does is it's how you create, how you produce and create the air layer, the distribution. The way it is done, as you can see on the vessel, there are multiple bands, and then air is not injected from one point. It is injected at various points. So, and we have seen that because with the distances, the efficiency starts to drop down. So the idea is to build up those layers with the lesser compressor power, maintain an air layer. So it creates a better and a fuller coverage of the flat bottom, and then each band can be controlled individually depending upon the sea state, or eventually with the injection strategy should come automatically with AI, machine learning, digitalization. What we see and what we believe, that with this air layer, you are able to reduce up to 50 to 75% of reduction in the specific drag. And then you can have, savings. And now, we have seen on the IMO slides, it says 5 to 7%. Under test conditions, we have seen up to 12%. Now these test conditions are still under ISO, and we see a lot of these percentages because these new technologies are a little bit difficult to verify. The standards are coming in, and these are all under test conditions. And being a seafarer myself, I know the ships don't run in ISO 15016 condition or sea trial conditions or swimming pool conditions. So we believe that eventually, on an average, you will get 3 to 5%, which is already substantial. And the system and the technology being fuel agnostic, I think it adds value. The more expensive the fuel is, the faster you payback time it. So you get a commercial, and you get your greener profile moving into that. I just wanted to summarize where it is. We have discussed about the integration of air lubrication and fluidics, which keeps a unique concept. We are the only ones in the market today who are trying to work on the air layer. We have the maximum efficiency. It is how it is distributed. We also discussed that. It's in the bands. With the bands, we are able to cover better flat bottom, more of it, and then we can create a better drag reduction, and then also with a better sea state. So that's something there. But most important, a lot of these technologies are very intensive. They could require a lot of modification to the hull. But the system here, the way it is designed, it's minimum 1 penetration per band. It can be done during dry dock. In fact, the last installation we were doing in China, they said, if it is only this, we can do it in 3 days. Yeah, but I have been in China 8.5 years. I would say at least a week. But we have seen that all the installations done so far, we have done it on a Ro-Ro. The original installation was on a coaster, 3,000 deadweight, which ran for about 2-3 years. And the recent installations, what we have done is on a Ro-Ro, on a LR2, on MR, Newcastle Max. But it all has been completed within the same dry docking period. It's also helpful for the new building because the shipyards don't have to change any design. It is just bolt on. You can bolt it or weld it, and then it remains there. But that's all about. But more than that, I think a product is a product. A machinery and a product, it always gives problems, sometimes here and there. And the important thing is, do you have a backing available? And that's where I think our global service team and support comes into play, and that adds the value overall to the unit. Maybe just a short video to capture that.
Our advanced Alfa Laval OceanGlide fluidic air lubrication system creates an air layer underneath a ship's hull. reducing friction, which is the most significant driver of ship resistance,
I think that's an
thus
issue with the
having a
sound.
direct impact on fuel consumption and the emission of greenhouse gases. Our air lubrication system makes sense not only from the environmental perspective, but also from the economic perspective. With fluidic air lubrication, you can expect fuel savings and emission reduction of up to 12%. Our solution is a combination of two innovative technologies. We install wing-shaped bands evenly spaced onto the hull that create and maintain a thin layer of air underneath the vessel. The wing-shaped bands have fluidic oscillators that produce a thin layer of air bubbles to reduce the friction between the ship's hull and the water. The installation process is easy and requires very limited modifications to the hull. We cover a larger area of the flat bottom of the ship, ensuring maximum efficiency to the air layer and the highest resistance reduction. The system can individually control each band, allowing it to tune the air layer, achieving high savings over varying operating conditions. With our fluidic air lubrication system, you achieve significant fuel savings and lower your carbon footprint.
Sorry about the sound. I think it was a bit muffled, but I think luckily we had subtitles there. It was just capturing what I just mentioned. We have few pilot projects running at this point of time. The vessel will be going into an optimization stage. And as I said, it is going to be a collaboration. So there are customers who have worked with us, and we are working to develop this technology. And it's not only that, Alfa Laval is involved into a lot of things, whether it is air lubrication, wind propulsion, solid oxide fuel cells, because our objective is that we would support the ship owners in whichever fuel pathway that is chosen, because that's been uncertain. So we will be there with you and to support. And a lot of information is available. Of course, yeah, we'll be happy to support. We would like to be more as an advisor in different technologies. Feel free to reach out our Alfa Laval office, Middle East team. We have some good people here, great people here with a lot of knowledge. Yeah, thank you so much.